This video shows details of how to solve the application problems in section 1.3. You may skip the details by reading through the PDF file only, which is in the same folder. And since this is a application section, most of the problems are story-based. So when we pick up each problem, we need to read it carefully and to see what conditions are given and what need to be found. Okay, let's start. Here comes example 2. Okay, a coffee house's daily costs are $252 when they sell 80 coffee drinks and $278 when they sell 120 coffee drinks. And assume that the daily cost C is a linear function. Okay, linear function of the number of coffee drinks x. So we need to A, find the function, B, explain the meaning of the slope, and C, explain the meaning of the vertical intercept. So let's start with the function. Okay, since the function name is C and the variable name is x, we have C equals, okay, and it's a linear function, so we get mx plus b. Okay, so for the linear function, we need to find the slope and the vertical intercept. So how do we find the slope? We are given two sets of data, x equal 80, and then c equal 252. When x equal 120, c equal 278. Since the slope is the difference in function divided by difference in variables, so we plug in x2, x1, and c2, c1, we have slope 0.65. And now plug in one of the points into the function. Say that 80 and 252. So we have an equation about the b. And solve for b, we have b equal 200. And that gives the function c equal 0.65x plus 200. Okay. Now next comes the value and the meaning of the slope. Now notice that for all the application questions, the units are very important, should be involved in the answer. So let's come back to see what's the unit given in x and c. Okay, so we see that x is given by the number of coffee drinks, and cost c is given by dollars. So the slope, the unit of the slope should be dollars over number of coffee drinks. Okay, so let's come back to C. Okay, so we have M, okay, and then we have dollars per coffee drink. So what does slope represent? Since this is a linear model, and we realize it's that for each additional cup of coffee, notice that this is the additional cup of coffee, which means if the coffee drink goes by 1, and then it's the cost goes by $0.65. And in other words, for if we add, if the coffee house sold one more cup of coffee, it will cost them additional 65 cents. And next comes to the vertical intercept B. And notice that the B represents the cost when x equals 0. So that is the fixed cost. And which means even if the coffee house does not sell any drinks, it will still have the daily cost of $200. And we can, put in all the fixed costs that you can think about, like rent, utilities, and employee wages. Okay, so the next example comes to the revenue function. And we have the same coffee house which sells the coffee for $3 per drink, okay, $3 per drink. And so we want to find the revenue function, and since revenue is price times quantity, and since the prices are fixed, we see that revenue is 3x. And if we want to find the profit function, then profit is revenue minus cost. So we have 3x minus 0.5x plus 200. So the answer is 2.35x minus 200. The part C asks us to find the break-even point, which means how many coffee drinks must the coffee house make and sell daily in order to break even. There's two ways to solve this question. One is setting up cost equal revenue, or since we already have the profit function, we can set profit function equals 0. Okay, so that gives solving the profit function equals 0. Okay. Profit function equals 0, and we get x is approximately 85 drinks. And notice that the coffee drinks must be an integer, so we just round the answer into integer. And so the answer should be 85 coffee drinks per day to make even. So next example is on marketing, and we want to find the equilibrium price and quantity if given supply function and demand function. And so how to find equilibrium price? And since these functions are, the variables are p, and we set SP equal dp and just solve this equation for p. Okay, by adding 3p in both sides and adding 40 in both sides. That way we moved all the unknown into the same side, and recombine, we solve for p, and we got p equals 20. So the equilibrium price is $20, and then we just plug in into either SP, okay, or dp to find equilibrium demand, x, quantity. Okay, so we find x equals 60, and therefore the answer will be the equilibrium price is 20 and equilibrium quantity is 60 items. Okay, so now let's look at exercise number 7. Okay, we have similar setting with cost function, and here is a radio manufacturing firm which has fixed cost of $25,000 and a variable cost of $8 per radio, and the company sells the radio for $16 each, and we want to find A, the cost function, and B, the revenue function, and C, the profit function. So since cost function is the fixed cost plus the variable cost, okay, so we add them together, finding the variable cost by looking at $8 per radio. That's the additional cost added on. And the revenue, again, is price times quantity, so we got 16 times x, 16x. And the profit, revenue minus cost, so we got 8x minus $25,000. Okay, so number D, we need to find a break-even point. So simply by setting P of x equals 0, we have x equal 3,125 radios. Now, number E, we want to plot the break-even point with the graph of the total cost function and the total revenue function. Okay, so here please pay attention of making the graph. And these functions have, these variables have quite high readings since the break-even point is more than 3,000 radios. So to set the scale of x, we need to make x to be at least 5,000. And now look at the break-even income or cost, and that is $50,000, which means the scale of y should be set quite high. Here we set up into $80,000, and that way when we plug in both the revenue function and the cost function, and we show the break-even point with as the intersection of those two functions. And next problem is exercise number 19. Again, we are given two functions, demanding and the supply, and we want to know, okay, at the price of 50, how many pairs of sunglasses, okay, here is, okay, the certain brand of sunglasses, will the consumers purchase? And which means we are going to use the demanding function, okay, by plugging P equal 50 into demanding function. Then we have the answer as 1,500 pairs of sunglasses in demanding. At the same price, how many pairs of sunglasses will the manufacturers supply? When we apply to the supply function, we got 600 pairs. And obviously, the market price. So what do you think? The market price should be higher or lower for the demand and supply to meet? And since in this case, there's higher demand than the supply, and the market price will be higher because people will willing to pay more to get the pair of sunglasses. Therefore, the answer should be the market price will be higher, okay, than $50. And part D asks what will the price have to be for the consumers to buy at least 1,000 pairs of sunglasses, and which means the demanding is 1,000. Okay, so we solve for P actually, and then we obtain P equal 100. So solving P for P from the demanding function, here comes, okay, 2,000 minus 10P and equals 1,000. So we got P equals $100 per pair. And then part E, okay, what will the price have to be for the manufacturers to supply at least 600 pairs? Again, we solve the equation for from the supply function to get P equal 50. Okay, and part F asks for the equilibrium price and the quantity. So we put these two equations together and solve for P, and we got a P equal 80. Again, plug P equal 80 into either demanding or supply, we obtain X E equal 1,200. And here comes the graph, okay, and since the equilibrium price is 80, we need to set P range from 0 to at least above 80, and here we set at 200. And since the equilibrium quantity is 1,200, we have to set up X range from 0 to at least above 1,200. So here I set up as 4,000, but you can set up either like 3,000 or 2,000. It will work. Okay, this concludes the video section of problem solving of section 1.3.